All right, guys, good morning. I know today's sort of a snow day, finger quotes, but I just wanted to put this up here for you guys because I told you this lesson was difficult on LeChat's principle, and I also wanted to give you guys feedback really quickly. So, we know that feedback, the quicker people get feedback on anything, the faster they can sort of implement, a change. And the longer we go without getting feedback, the more likely it is that, you know, it might not be as helpful. So I wanted to get this to you guys right away. I'm going to give you guys this feedback. I'm going to give you guys a little video to look at over the weekend as well. All right, so for number one, very quickly, I'm not using the video camera because I ran downstairs really quick and I'm not working today, so to speak, but I'm just going to post this quickly. All right, so for the exit slip, look at the equation that represents a reaction at equilibrium and answer questions 1 and 2 that follow. We have water plus carbon dioxide forming carbonic acid, and we're being told off to the right here that the delta H is positive. For question 1, explain what direction the reaction would shift and what would happen to the concentration of H2CO3 if more CO2 were added to the reaction. So what will happen to the concentration of this, which is a product, right? If we add more carbon dioxide to the reaction. So if we add more stuff here, what will happen to this? That's what the question's asking. So let's erase and we'll use our seesaw analogy and we'll come up with an answer. So here we go. Again, it says that we are at equilibrium. So initially, this whole thing is, here's my triangle, the middle of the seesaw, right? We are at equilibrium. Everything's equal, nice and level. The rate of the forward reaction equals the rate of the reverse reaction. But now we're going to add more CO2. It says we're going to add more CO2. Well, CO2 is right here, right? So if you add more weight on this side of the seesaw, it's suddenly going to look like this. It's going to get out of balance, right? So we've added more weight over here. So now the question becomes, which direction will it shift? It says, tell me which way it would shift. And I always recommend that's how you start your answer. Which way will it shift after you add the thing or you remove the substance? And then think about answering the second part of the question. But first, you have to tell me which way it would shift. Well, if the left side over here is lower and the right side sticking up in the air, this would have to shift to the right. So this reaction, the first part of this is, which way will the reaction shift? The reaction will shift to the right. Okay, and that's the first thing you should have said. So as I sort of scrolled through, I sort of saw every combination of answers here in your exit slips, but the reaction is going to shift to the right. Now, what do they want to know? The one mistake that I think I made in my lesson is I just talked about what would happen to the concentrations of the reactants and products, generally speaking, and this question is asking about the concentration of a specific substance. Well, at the end of the day, I'll switch colors one more time. At the end of the day, the goal is to determine what's going to happen to this concentration, right? So what's going to happen to the concentration of H2CO3? If the reaction is shifting to the right, the concentration of my products will increase because you're making more products. As you shift to the right, that shifting to the right means you are making more product. And what that means is you're using up your reactants to do that. So those concentrations will go down. So in this case, if you have a reactant, the concentration will decrease. And if you have a product, the concentration will increase. Well, the question says, what would happen to the concentration of H2CO3? And H2CO3 is a product. So the concentration of H2CO3 will increase, okay? So the two things you should have said, the reaction will shift to the right, and the concentration of my product, which is H2CO3, will increase. All right, so that was the answer to number one. Sorry, bear with me here. Ugh. All right, so there you go. Sorry. Your two answers for number one, the reaction should shift to the right and the concentration should increase. Number two. Okay, number two. Is that going to work? How about that? That's pretty fancy. Oh, I'm still going to have to erase all this stuff, so we're going to erase it. All right. Now, number two is a little bit trickier. I did, tell you guys that it can also ask you about heat. What happens if you increase the temperature? And sometimes they just put the heat in the equation where it belongs, but other times when it's more difficult, they put it off to the side like this, and you have to put it where it belongs. Well, it was a short part of the video, but delta H is being written here off to the side with a positive charge, and excuse me, a positive sign, which means it is going to be endothermic. And what that means is it belongs on the reactant side. Okay, so that means when it's positive, it belongs on the reactant side. So I'm just going to add it over here, 80 kilojoules of heat. Okay, just 80 kilojoules. There it is, right, in all its glory. So you got 80 kilojoules of heat. Perfectionist here. 80. Wow, this is tough to do. So 80 kilojoules will be a reactant, okay? We're going to treat it like a reactant. It belongs on the left side of the equation, and then it sort of hangs out with water and CO2 like the other reactants. So that's all you have to do. The first thing that you have to deal with is put it on the right side according to the sign. If it were a negative sign, you would put it over here with the products. When it has a positive sign, it goes over there with the reactants. At that point, it becomes exactly like the previous question. All right, so what would happen to the concentration of H2CO3 if the temperature was decreased? All right, so let's go over that quickly. Again, pretend for a minute that everything is at equilibrium, right? So there's your triangle. Everything is nice and level at equilibrium. Suddenly now you are decreasing the temperature. You are taking away from this side. So if you can imagine you have like, you know, 3 people on this side and 3 people on that side. If you're going to quote take away something on one side, that's like one person jumping off. So we're taking away from the left side. So what's going to actually happen is that it's going to shift like this again. The left side of the seesaw is going to get lighter, which means it's going to go up. So when you remove temperature, which is on the left side of the equation, that left side goes up. And so that means the reaction is going to have to shift to the left. Okay, so the first thing, what way would the reaction shift? The reaction is going to shift to the left for number 2. Okay, and again, once you get to that point, hopefully it's pretty self-explanatory. The reaction will shift to the left. And again, if you're going to the left, you're going to be making more reactants and you're going to be using up your products. So my concentrations of reactants are actually going to increase. My concentration of my product is going to decrease. Well, they're asking about, again, your product, and the only product we have is H2CO3. So the concentration of H2CO3 will decrease. Okay. All right, guys. So that is your exit slip feedback. Like I said, it's just a quick little video. I'm going to post this, and like I said, I've actually made like the next 5 lessons for you guys, and I would absolutely hate for you guys to have nothing to do this weekend. So I'm going to post for you the second part of the video on Le Chatelier's principle. So we have Le Chatelier's principle where we have the seesaw for concentration and temperature. There's a second rule for Le Chatelier's principle that deals with pressure. I'm going to post that video along with this video for your exit slip feedback. Check it out, and we'll regroup on Monday, Tuesday. All right, guys, have a great weekend.